In this video, we are going to discuss on past paper 2 questions, past paper 2 questions that have been randomly selected. So we have a series of these past paper 2 questions that have been randomly selected from the past years. So we will be discussing them. But before we continue, I really want to thank those of you who have taken your time to subscribe to our channel. We are not asking you to donate or buy pamphlets Our resources are free. We are really interested in your success. What we want from you is for you to subscribe to our channel, share to other fellow learners, and like the video. That is the only contribution we want from you. Let's get started. We are starting with intermolecular forces. These are some of paper 2 questions on intermolecular forces. With question number 1, pentane has 2 structures. 1, N-pentane with a boiling point of 36 degrees Celsius, and isopentane with a boiling point of 9 degrees Celsius. Explain. You are given a question like this one. The first thing you need to know, what is N-pentane and what is isopentane. They are all isomers. All these are all isomers. The N-pentane is the normal pentane you see, which is CH3, CH2, 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 CH3. And the isopentane is just an isomer of it, which you were to name it, you will say it is 2,2-dimethyl propane. 2,2-dimethyl propane. So now, starting with the N-pentane, why is it having a higher boiling point than the other isomer, which is isopentane? This structure for N-pentane, this structure is linear and has a larger surface area with more contact points, resulting in strong van der Waals forces. It is linear, it has more contact points, it has a larger surface area, and all these result in what? Result in more van der Waals forces. And when there are more van der Waals forces, the force of attraction between the molecules becomes stronger and will require what? Will require more energy to overcome it. The isopentane, the isopentane, which you can name it following the IUPAC system of nomenclature as 2,2-dimethyl propane. This structure has a spherical shape. The structure has a spherical shape with a small surface area and less contact points. Once more, it is spherical, has a small surface area, less contact points with other molecules. And for this reason, there are less van der Waals forces. holding the molecules together. And with that, the van der Waals forces are weak. They are weak, and just little energy is required to overcome them. So that is how you can differentiate between them. Question number 2. We have A, which is methane, B, which is ethane, C, which is propane, and D, which is butane. Their boiling points are increasing as the number of carbon atoms are increasing. They are telling you, explain why there is an increase in the boiling point as the carbon atom increase. It is simple. We say boiling point will increase from A to D, that is from methane to butane, due to increase in the number of electrons, as well as increased contact points, causing the instantaneous dipole, induced dipole forces holding the molecules together to be stronger. So, as the molecular weight or as the molar mass is increasing from methane to butane, what happens? There is an increase in the number of electrons. There is an increase in the contact points between the molecules. And when there is an increase in the number of electrons, an increase in contact points, what happens? There is increase in the instantaneous induced dipole attraction. And when there is an increase in instantaneous induced dipole forces or van der Waals forces holding the molecules together, what happens? The boiling point will definitely increase, and it will require more energy to overcome them. Let's go to the third question. The third question. Non-metallic elements are generally non-conductor of electricity. Explain why graphite does conduct electricity. Of course, graphite being an allotrope of carbon is expected not to conduct electricity. But it does conduct electricity because graphite, instead of 4 bonds, is bonded only to 3 other carbons. The 4 electrons that are supposed to be bonded to 4 other carbons are bonded to only to 3. There is 1 electron there that is loose and is delocalized. It is this delocalized electron that is not bonded that result in giving graphite the property to conduct electricity. Question number 4. Explain why boiling points of halogen increase from fluorine to iodine. You see the boiling point of halogen, fluorine, chlorine, bromine, and iodine. Their boiling points are increasing as you go down the group. Why is this so? Explain. The simple answer is electron increase as the molecular weight is increasing. With increased molecular weight and the number of electrons, what happens? The van der Waals forces will increase down the group. Again, as the molecular weight is increasing from fluorine down the group to iodine, the number of electrons are also increasing. An increase in the number of electrons will result in what? Will result in increase in the van der Waals forces, or will make the van der Waals forces to be stronger and stronger, and resulting in what? Resulting in an increase in boiling point. Let's go to the next one. We are now going to deal with the halides. Halides. hydrogen halides. Explain the trend in boiling point from hydrogen chloride to hydrogen iodide. Explain why the boiling point of hydrogen fluoride is so much higher than the boiling point of hydrogen chloride. It is simple, very simple. Increase in the number of, as you move from hydrogen chloride to hydrogen bromide to hydrogen iodide. What happens? There is an increase in the molecular mass. And when there is an increase in the molecular mass, there is also an increase in the number of electrons. With increase in the number of electrons, increase in the van der Waals forces holding the molecules together. Finish. Increased number of electrons from hydrogen chloride to hydrogen iodide lead to increased van der Waals forces between the molecule. It's finished. Then number 2, explain why the boiling point of hydrogen fluoride is so much higher than the boiling point of hydrogen chloride. If you look at the boiling points here, you will see that hydrogen fluoride has an exceptionally very high boiling point than other hydrogen halides. The reason is simple. The reason is that there is the presence of hydrogen bonds in hydrogen fluoride molecule. There is the presence of hydrogen bond. And a hydrogen bond, bonding is a bond. This is a bond from when hydrogen attached to a very strong electronegative element. Hydrogen attached to a very strong electronegative element is attaching itself to what? To a second electronegative element. For instance, you see hydrogen atom is very electronegative. Yes. Hydrogen bonds form between hydrogen fluoride atom of one hydrogen fluoride molecule and a hydrogen atom on a neighboring molecule. Hydrogen bonds are stronger than van der Waals forces. What you find in hydrogen chloride, hydrogen bromide, hydrogen iodide are what we call the van der Waals forces, which are resulting from increasing number of electrons and the molecular weight. But this one, there is the presence of hydrogen bonds there. That is what gives hydrogen fluoride an exceptional high boiling point. Thank you, listeners. Once more, I just want to remind you that if you have not subscribed to our channel, please subscribe. But please do not go without hitting the notification bell.